Okay, in this practical we are going to measure the mass of a metre ruler using the principle of moments. Okay, dead simple this. All we need is a pivot, so we've got like a triangular block of wood. That's going to act as the pivot. We have some 10-gram masses and some string. And that is literally all we need to accurately measure the mass of the metre ruler. So first thing, we need to locate the centre of mass of the ruler. Okay, the way we're going to do that is obviously balance it on the pivot. Right, so with a regular object, with a regular shaped object, it's fairly straightforward to locate the position of the centre of mass by balancing on a pivot. Okay, so let's try and get this fairly close. So as you can see, that's just about balancing. That looks spot on. So I think that's on the 53. On the 53 mark, that looks like that is where the centre of mass of the ruler is. Okay? So, next up we need to basically move the centre of mass to one side, and then we hang from the other side the slotted masses. Okay, it's as simple as that. Right, firstly, I'll do it 3 times, so it'll give us 3 different values of slotted masses and distance from pivot. So this is, including base, this is 20 grams. Okay, so 10 grams plus this is 10, the base is 10 as well. So let's hang that over. Okay, so remembering the centre of mass position on the metre ruler is 53. Okay, sorry, 50.3 centimetres or 503 millimetres. Right, let's keep the position of the slotted masses constant. Okay, I'm going to keep the slotted masses at 95 centimetres or 950 millimetres. Right, so all we need to do now is to position it so that the thing balances again. So once we've got it balanced, the anti-clockwise moment due to the weight of the ruler and the clockwise moment due to the weight of the slotted masses should balance. Right, so that looks pretty spot on. Okay. That looks pretty spot on. I don't know whether you can see that. The metre ruler position there. Okay. Right, I'm going to go with 585 millimetres. Okay. 585 millimetres. Right, let's try a different number of slotted masses. So add 2 more. Now we've got 40 grams of slotted masses. Let's keep the position constant. Okay. Now, so slotted masses are at 950. Now the pivot is now at I'm going to go with 642. So the pivot is at 642 millimetres, and the slotted mass is at 950. Let's try one more. Now we've got 60 grams 60 grams on the slotted masses. Let's keep that at 950 millimeters. And that looks pretty spot on. So I'm going to go with 684. 684. Maybe a bit more. Yeah, 685. There you go. You see the slotted masses. So pivot position now is 685 millimeters. Slotted mass position is 950 millimeters. Centre of mass position is, what did we say, 503 millimeters. Right, you can use those values to work out the centre, to work out the mass of the ruler. One last thing, here's the actual mass of the ruler. The actual real mass of the ruler is 89.62 grams. Right, so see how close you can get to that with your moments calculations.